Okay, so I'm looking at irishelectronics.ie, and here we have an operational amplifier, an 8-pin microchip. It looks very like a 555 timer, but it's an operational amplifier. It does two things. It'll amplify current, just like a amplifier for a guitar, for acoustic guitar, and it'll also work as a comparator, where it'll compare voltages and it will output in two different ways. It'll output current out or current in. So it'll source current out or sink current in, which is quite unique for a component. Okay, so let's have a look at the amplifier, or the operational amplifier here, in its amplifier mode, which would be like this circuit here. Okay, so here we have the circuit diagram for the operational amplifier. It's that triangle there. Okay, you don't want to mix it up with an inverting NOT gate for logic gates. Nothing got to do with that. Okay, it's a triangle, and it's got a non-inverting input and an inverting input here and here. Okay, no current goes in here, just voltage, and it'll amplify the output voltage here. Okay, now let's have a look at the voltage gain. If you're asked to calculate it, it's AV is your voltage gain, is equal to 1 plus resistor R2 divided by resistor R1. And you'll also see an example on page 243 in the book. Okay, now the comparator circuit on page 244 in your Leaving Cert book is a circuit that looks something like this. Okay, where here is our operational amplifier, and we have a 9-volt DC circuit. We got an output over here of two LEDs, red LED. This one's a green LED. Each LED's got a resistor to protect it, and we got two potential divider circuits going into our operational amplifier. So the first potential divider circuit here, okay, has a thermistor here. Okay, so our input sensor for this circuit is a thermistor, so it's going to sense hot and cold temperatures, and that's going into our non-inverting input plus. All right, our non-inverting input plus. And we also have another potential divider here, and this is to help us control our operational amplifier, and that one is going into our inverting input, negative here. Okay, so we got two voltages going into our operational amplifier, and we have an output here. Okay, now remember, the output for the amplifier in this case can source current out, and it can also sink current in. Okay, all right, so let's have a look at it in operation here. Now, this circuit would be for a freezer. Okay, with a green LED to say that the freezer is good and the temperature is low and the food inside is fine. And there's a red LED on the freezer to say that the temperature inside the freezer has gone up and that needs to be sorted out. Okay, there's something wrong. So I put two probes, a red probe here and a blue probe here. They're represented down here, and we can see the voltages that they're at. Okay, so in this circuit right now, okay, we have a voltage of 1.6 volts for blue, which is here, and we have a voltage of 2.71 millivolts, which is the red one down here. All right, so they will change, and when they change value, when one goes higher than the other one, the red LED will come on, and when the other one goes higher, well, then the green LED will go on. All right, so when these voltages change, our outputs change. Okay, and this sentence up here explains exactly it. If the non-inverting input, positive one, is at a higher voltage than the inverting input, then the output will source current out. Okay, it will source current out. If the inverting input is at a higher voltage than the non-inverting input, then the output will sink current in. Okay, so we look at the current and the voltages and we'll watch it now. Okay, so here we have the red LED is on, so our temperature is probably quite high, yeah? So let's bring the freezer down. Okay, so the freezer's at -20 now. Okay, and we can see that our input voltages have changed over. Okay, so we can see that our non-inverting input, this one here, the red one, is at 3.8 volts, which is higher than our inverting input, which is at 1.67 volts. So this one is higher than this one. And now our voltage is sourcing current out.